Even though you are new in data analysis, you might have heard about mean, median, or mode once in the past. But another important aspect of descriptive statistics includes the measure of dispersion. So if you are curious to know what it is, why is it needed, and how to implement it, stick to the video and I will be answering each of these questions. As a data analyst, suppose you have two smartphones and you want to compare the battery performance of both of these models. Now you collect the data of battery life of both the phones and get stuck on which statistical measure should I use to compare them. Well, the answer to this will definitely be measures of dispersion. Now I have told you the answer, but if you want to know how to use it and analyze which smartphone is better, then keep watching. So measures of dispersions are like treasure hunters in the world of statistics. They reveal the extent to which data points deviate from each other. It's not just about knowing the center of our data, but understanding how spread out the values are. In the video, I will be explaining you three measures of dispersion. Number 1 is range. Range is a simple measure of variability in statistics, and it represents the difference between the highest and lowest values in the dataset. It gives us a quick understanding of the spread of the data without considering the distribution of values. The range is easy to calculate and provides a basic sense of the data's range. To find the range, you simply subtract the lowest value from the highest value in the dataset. Let's take the smartphone example once again and try to understand the range of battery performance in hours. So we have model A with 8, 9, 10, 11, 12 hours of battery lives, and model B with 6, 9, 10, 14, 15 hours of battery life. So the range would be approximately 4 for model A and 9 for model B. It shows that model B has a wider range of battery life compared to model A. The next measure of dispersion is the standard deviation. The standard deviation is a more comprehensive measure of variability, taking into account the differences of all the data points from the mean. It quantifies how much the data points deviate from the mean. So the standard deviation of model A would be under root 1.6, which is approximately 1.26, and that of model B would be under root 9.62, which is approximately equal to 3.10. Now if I square the under root values of A and B, I get another value, which is the third measure of dispersion, also known as variance. In simpler terms, variance is another measure of variability in statistics, and it is nothing but the square of standard deviation of the data point. So the standard deviation or variance reveals that model B has a greater variability in battery life compared to model A. The larger standard deviation indicates that the battery life data points in model B are more dispersed from the mean, reflecting a wider range of experiences among the users. And that's not all. By combining measures of dispersion with measures of central tendency from our previous video, we can paint a complete picture of our data story. If you want to know more about central tendencies, click on the video to the left, and if you want to know how to implement those statistical terms using NumPy, click on the video to the right, and I will see you there. Till then, keep learning and thanks for watching.